this session, we will discuss schema design examples. Let us consider an example of a point management service and walk through its schema design. Point management services have become a common feature almost for everyone. They usually have two main functions. One is a summarized point information for each user. It is assumed that user information is managed by a separate service, such as user service. In the point management service, the point information is linked with key information of user service such as user ID to identify the information for each user. And the other feature is points history. It keeps a record of the date on which points are issued, the corresponding transaction, and so on. Let us define some simple requirements for this service. This service manages points for each user. We assume that the user information itself is managed by a separate service. Points are issued to users based on related service transactions such as hotel booking, flight booking, and similar. This information is managed as points history. Another requirement is to manage summarized points information such as available points, time-limited points, and so on. So it is not required to calculate the necessary data frequently. The next requirement is to manage points history for each user. Also, points history can be filtered with defined periods, including last 30 days as default option. Based on all the requirements, we define columns: point summary and point history. Here, look at the column names, which are checked to determine the partition key and clustering key. Let us understand the common conditions for defining partition keys. Select columns that you do not update later. Select columns whose values cannot be null. Column values has a large range of possible values, which means high cardinality. First, let us consider point summary table. As mentioned before, the partition key is very important. We can see that in the point summary table, only user ID fits all the conditions required for defining the partition key. The point summary record is one per user. It means we can uniquely identify the target record only with user ID. In this case, we can think there is no need to add a clustering key. Next is point history table. For this table, not only user ID but also transaction ID also meets partition key conditions as specified. The information in point history is primarily used by users. If we use transaction ID as the partition key, it ensures that most records for a user are distributed across different partitions. It will be a bad query. If you use user ID as the partition key, all related records will be in the same partition. Therefore, user ID is probably a better choice for the partition key. For this table, there are multiple records per user ID. A clustering key must be defined to identify the target record. Let us understand the conditions for defining the clustering key. The first thing is, we need to identify a record by using a partition key and a clustering key. This condition is essential for ScalarDB schema. The second condition shows the condition same as that of the partition key. Select columns that you do not update later and values cannot be null. The third condition is from requirements of the functionality. Points history needs to be filtered by issued date and time. As we discussed, range conditions can be applied to the last column in the set of clustering keys. Assuming that there cannot be two history records occurring at the same time for the same user, issued date time is the most suitable clustering key. As we want to use a range condition, transaction ID is not suitable as a clustering key. However, this value is unique within the system. It is useful for identifying the target record with a single column. Therefore, we define it as a secondary index. Let's check using sample records. Identify the partition or records using user ID as a partition key. We can filter records using range conditions. Issued date time is greater than May 17, 2024. And issued date time is less than June 17, 2024.